Hello students, welcome to the first video of this new playlist. So in this new playlist, I'll be solving January 2024 Statistics 1 S1, that is S1 paper. So under this playlist, there will be 8 videos since there are total 8 questions in this Statistics January 2024 paper. So in each of the videos, I'll be solving each of the questions of this paper, and I'll try to explain each of the questions as much as possible in each of the videos. So the video length might be a bit long, so I'll suggest you to watch the videos in making it faster by 4 times or 2 times. That will be fine. Okay, so since this is the first video, we will be solving question number 1 from this paper. So let's see what's the question number 1 is about. So the concepts, if I give a short review before starting question number 1, the concepts behind question number 1, it's basically from the second chapter of statistics book, that is measures of spread and location, since interpolation method has been discussed in that chapter. Then you should have idea about histograms and skewness, which has been discussed in chapter number 3 of your statistics textbook, which is representation of data. And also you need idea from probability chapter, that is chapter number 4 of your statistics book. So definitely, in order to able to understand this solution of this question, you should have finished or you should have done these chapters. Okay, so let's get started with the first question of this paper. Okay, here they are saying the histogram below shows the distribution of the heights to the nearest centimeter of 408 plants. Okay, the total frequency here, it's what? 408 plants. Okay, this is a histogram. Okay, so for a histogram, we know that along the x-axis the class interval is taken, right? And along the y-axis the frequency density. Okay, so in part A, they're asking to use the histogram to complete the following table. Okay, we need to complete the table, the following table. There something is missing. What is missing there? This one and that one is what missing. Okay, so we need to find out the frequencies for these two classes, right? Okay, so in order to find out the frequency, what we need? The area, right? We know that in a histogram, the area of the bars is basically proportional to the frequency. Okay, so what we can do here is that the problem would be along the y-axis the labeling for the frequency density is not given, right? Okay, so but we know the frequencies for 3 of these classes, so we can use these frequencies to figure out the what? We can figure out the the frequency density, the labeling along the y-axis, the scale along the y-axis using the frequency of these 3 given values, 3 given frequencies. Okay, so let's see. Since the area of a bar is proportional to the frequency, so we can use this concept. Look, at first consider which one. We can consider this bar, any bar you can consider. Let's do work with this bar. This bar is from which part? It's from 10, 11, 12, 13. Yeah, it's from 13 to 15. So which group is this? This one. Okay, so from 13 to 15 the frequency is 120, right? So what's the class width? The class width is 2 and frequency is what? 120, right? So that means we know that the area, what would be the area? Area is what? 2 times along the y-axis, what you can see, it is 1 unit, 1 2 3 4 5 6. Okay, this is 6 units along the y-axis, but The thing is that we are not sure, since the frequency density is not given, so we are not sure whether this is 1 or not. Okay, so we will consider the scaling factor, like it is called the scaling factor. We will consider this as 1k, this as twice of k. Okay, this as the next one as thrice of k. Like as that, we will consider the scaling along the y-axis, because we are not sure with the scaling. Okay, so consider the area of this bar. What we can say, 2 times what? 2 times how much? The class width is 2, and along the y-axis the frequency density is 1 2 3 4 5. Okay, 6k, right? 2 times 6k times what? 2 times 6k, this is equals to what? This is equals to 120, right? Because we know that area of a bar, it is proportional to frequency. Okay, so area of bar is what? Proportional to frequency. So frequency is this one, and this is basically the area of bar. So basically the area of the bar is 2 times 6, but k is basically the proportionality constant. Okay, so k equals to what? So k equals to, like, this proportionality constant is basically what? The scaling factor. Okay, this is the scaling factor. Like along the y-axis, what the scaling has been, what's the scaling has been used. Okay, so 120 over 12, that would give you what? The value for k is 10. So we got the value for k. That means 1 unit along the y-axis is what? 10 frequency density. Okay, so we got the value for k, we got the scaling factor. Now that's very easy work to find out the frequencies, isn't it? Look, from 15 to 17, this is what? 15 to 17. From 15 to 17, how many units along the y-axis? 1 2 3, and then what? 3.246. so 3.6 times what? 10. Or you can say this is 30, 32, 34, 36. This is 36. The frequency density is 36. So 36 times the class width. What's the class width here? The class width is 2. So 36 times 2 is 72. Done. Next is for this class from 17 to 25. The class width is basically 8. So 8 times how much? 2 4. So 4. So this is 32. Okay, this is 32. Just I'm finding the area using the what? Using the scaling on the y-axis. Done. This is part A. Okay, so next for part B, if you just this working, you can do it here. This is basically rough works. Okay. Okay, for part B, they are asking use interpolation to estimate the median. We need to use interpolation to estimate the median. Okay, let's consider one thing. Median. Most of the students feel very difficult to memorize or keep remembered the formula for interpolation. So basically, I can show you a formula that will make your process very easy for finding the median using interpolation. So right at first in this process, what we will do, we will find out the median class. What's the median class? The median class is basically the class where the middle value, that is Q2, lies. So how can you figure this out? Okay, let me show you how can we figure that out. Look, for part B, Q2 equals to what? N over 2, right? 408 over 2. That would give you 204th term, which lies where? Which lies, you don't you can write, or you can ignore, no problem. 204th term which lies in which class? In the class. Okay, let's see where does this 204th term lies. Look, This is 32 plus 152, which is 184. 184 plus 120, which is 184 plus 120, which is 304, right? So 304. Okay, 204. Okay, we need 204. So this is 152. So that means it lies, the 204th term lies here. The sum of these two is 184. So that means here it will, the 204th term be lying. Okay, so the median class is what? h greater than or equal 13, less than what? 15. Done. Okay, we got the median class. Now we will use a direct formula for finding the median. Let's have a look. Q2 equals to L plus n over 2 minus fc into what? Times h over fm. This is basically an arranged formula for interpolation method. This has been derived from interpolation method. L is basically the lower limit of the what? Median class. So what's the lower limit of the median class? This is 13, right? This is what? This is 13. Okay, so lower limit of the median class is 13 plus n over 2 is 204 minus fc. fc is basically the cumulative frequency of the previous class to the median class, which is 184. Okay, times h over fm. The h is basically the class width. Class width is what? 13 to 15, which is 2 over fm. fm is the frequency of the median class. So what's the frequency of the median class here? Which is 120. So the frequency of the median class is 120. So let's figure out the value for Q2. So 204 minus 184 times 2 over 120, which gives 1/3 plus 13. This is basically 13.33, or you can write in exact form, which is 40 over 3. What is it in centimeter or millimeter? Definitely it should be in centimeter. Yeah, it should be in the centimeter. Okay, so this is basically the what? Q2, the median. Done. Next. Okay, so we got the median, which is 40 over 3 centimeter. Done. Next, for part C, what they are asking here, the mean height of these plants is 13.2 centimeter, correct to 1 decimal place. Okay, the mean height of these plants is how much? 13.2 centimeter, correct to 1 decimal place. Okay, describe the skew of these data, giving a reason for your answer. Okay, so we need to tell the skew, like how the data is skewed. We need to tell it from the what? From the values. Okay, from the values of mean and the median, and also considering the histogram. Okay, let's have a look on the histogram. From the histogram, if you check out the histogram, you can see that it is almost symmetrically, that is uniformly distributed, right? The mode is at the middle, the mean also lies here, the median is also lying there. Okay, okay, we got from the first consideration is the histogram. From the histogram we can figure out that it is almost symmetrically, that is uniformly distributed. Second thing is that the mean, the value for the mean is 13.2, and the value for median we got what? 40 over 3, that is 13.3, which is just what? 0.1 greater, right? That means it is almost equal, right? So that means we can say that since it is almost equal, we can consider the mean and the median are both are equal up to 2 decimal place. We can consider up to 2 significant figure, both are equal. So that means the data is uniformly distributed. Make sense? The data will be uniformly distributed. Like you might get confused here, like what to say, because the median, there is a difference of 0.1. So you might say that it is what? It will have negative skewness, since from the formula that is 3 times mean minus median over standard deviation, this formula suggests that the skewness will be negative, but still it will be what? Symmetrical, uniform, because there are two evidence. The first evidence is that the histogram, and the second evidence is that the median and the mean are equal to each other up to what? 2 significant figures. Make sense? So for part C, what we can say? It is uniformly, there is no skewness, no skew, since what? Since mean is almost equal to what? The median. It's almost equal to the median. Okay, since mean is almost equal to the what? Median. So that's why it has no skew. Okay, and also, like, if you want to mention the histogram, you can also say what? You can say mean is almost equal to the median, or you can say the histogram is almost what? Symmetrical. It's almost symmetrical. You can either say this one or that one. Okay, for part D. Next. Okay, so let's see part D, what they have asked in part D. 2 of these plants are chosen at random. Okay, they are choosing 2 plants at random. Okay, part D asks to estimate the probability that both of their heights are between 8 cm and 4 cm. Okay, both of their heights are between what? 8 and 14 cm. Okay, so we need to find out the probability, right? So let's find out for a single chosen plant, what would be the probability to have a height between 8 and 14 cm. Look, at first we need to consider here, like, what would be, where would be 8 and 14. So this is basically what? 8. This is 8. So 8, 9, 10, 11, 12, 9, 10, 11, this is 11, this is 12, 13, and then what? This is the 14. So this is 14. Okay, so now we need to find out the frequency between 8 to 14, right? How can you find out that? Find out the area. First area is what? Like, this area is basically, class width is 8 to 9, right? 8 to 9, which is 1 unit. So 1 unit, and along the y-axis the frequency density is how much? It's 8. Okay, so 8. So we got the area 8 here. The area is 8. So frequency is 8. Okay, now from 9 to 13. So 9 to 13 is how much the area is? This is pretty straightforward. 5 times what? 5 times 10, 20, 30, and then 38. So 38 times 5, right? 38 times, this is 5. Or it's from 9 to 13, so it will be 38 times 4. Okay, 38 times 4. And at last, from 13 to 14. From 13 to 14, what would be the area? 1 unit, only 1 unit. And along the y-axis, the frequency density here, it's what? 60, right? It's what? 60. Now, so we got the total probability. There is 8 plus 38 times 4 plus 60, right? So if you want to find out the probability, we got the total what? Frequency. Which frequency we got here? The frequency for what? frequency for what? H greater than or equal 8, less than or equal what? 14 is how much? We got 8 plus 38 times 4, that is 9 to 13, and then plus what? 1 times how much? 60. So the total frequency is 38 times 4 is basically 152 plus 38 times 4 is 152. Okay, and then 8 plus what? 60. This is 220. Okay, this is 220. So we got the frequency. Now the probability that two trees have height what? Greater than or equal 8, less than or equal how much? 14. Okay, this is what? On the first pick they will pick it randomly, right? So the first pick and then the second pick. Look, on the first pick the probability of a tree to be within that height, this is 220 over 408. Now one tree has been picked up from that height already, so that means the frequency will decrease by 1. So that means 219. On the second pick it will be 219 over what? There will be one less tree, that would be 407. Make sense? So 220 over 408 times 219 over 407. So the value would be what? 0.290. This is the probability up to 3 decimal places. Okay, that's the answer for part D. And that's all about the first question from Statistics 1 January 2024 paper. That's it.